How to read a manometer by Natalia Lacutir. The manometer is an instrument that helps you measure pressure. This could be atmospheric pressure or the pressure of a gas or liquid. There are two types of manometers, closed-ended and open-ended manometers, which consist of a mercury-filled tube that is shaped into a U. At the end of this video, you will know how to read both types of manometers. Remember that the standard atmospheric pressure is 760 millimeters of mercury. How to read an open-ended manometer? The open-tube manometer is used to measure the pressure of a gas in a container. As you can see, one end of the manometer is open to a container filled with gas, while the other end is open to the atmosphere. Before we start, remember that the pressure of a gas is given by H, the change of height in the mercury levels. There are three situations we should learn in measuring pressure of a gas by the help of atmospheric pressure. First, whenever the gas pressure is less than the atmospheric pressure, the equation to use is gas pressure equals atmospheric pressure minus H. The second situation is when the gas pressure is greater than the atmospheric pressure. The equation to use in this case is gas pressure equals atmospheric pressure plus H. And the third situation is when the atmospheric pressure is equal to the gas pressure. In this case, H would be 0, so the gas pressure would have the same value as atmospheric pressure. Okay, so let's start with example number 1. As you can see, the mercury is not even on the two sides. This happens because the gas is pushing the mercury down on the left side, and on the right side, the atmospheric pressure is also pushing the mercury down. In this case, the gas pressure is stronger, so you would use equation number 2. First, you need to find the H. You do this by subtracting 500 from 800, which gives you 300. Remember that the standard atmospheric pressure is 760, so you add 300 to the 600 and get that the gas pressure is 1060 millimeters of mercury. Now, let's pass on to example number 2. In this case, the mercury levels are even on both sides. This means that the atmospheric pressure is equal to the gas pressure. The H value for this problem would be 0, so the gas pressure is 760 millimeters of mercury. Example number 3 shows the third situation we should learn when measuring the pressure of a gas by the help of atmospheric pressure. As seen in the graph, the mercury level is higher on the left side because the atmospheric pressure is greater than the gas pressure. In this case, we would use equation number 1. The H value is obtained by subtracting 600 from 800, which gives us 200. After this, 200 are subtracted from the 760 of atmospheric pressure to get 560 millimeters of mercury, which is the gas pressure for this exercise. How to read a closed-ended manometer? Closed-ended manometers look similar to open-ended manometers. You have a chamber that contains a gas. However, the end that is normally open to the atmospheric pressure is sealed. To get the gas pressure in this type of manometers, you just have to measure or calculate the difference in the mercury level heights. In contrast to the open manometer, the equation for the closed ones is just pressure of gas equals H. Example number 1. In this exercise, the mercury level is the same on both sides. Therefore, the H value would be 0. And since the pressure of gas equals H, the pressure of this gas would be 0 millimeters of mercury. Example number 2. The mercury level is higher on the right side. So to get the gas pressure, we find H, which is 200. Therefore, the gas pressure in this case would be 200 millimeters of mercury.